Hello and welcome back. This time we're taking a look at the inputs to the Gemini API to understand what's going on and how we can change its behavior. Let's get right into it. We are starting things off again with Python, where I have added a new thing to the code. Here you can see this input config, where we can specify 5 parameters. Now, these parameters are used to change how the LLM responds to us. Let's take a look. First up is the temperature. With a value ranging from 0 to 2, it specifies the randomness of the answer from the model. 0 meaning it's as predictable as possible with these models, and 2 as random as possible. Next is the maximum output tokens that the model can produce or answer with for our request. In this case, limiting it to up to 800. Next is top P. This limits the amount of total probability from the possible output tokens which the model can respond with. This contrasts with top K, which enables us to set a limit of the number of tokens that are considered. So it's a much more hard stop, meaning it's enabling us to set only a consideration space of 10 as the answers. Next is the candidate count. And now, if you've been paying attention in the past, you might have already considered yourself asking, hey, wait, in the outputs, we always talk about candidates 0. That kind of implies that there's more than one, and there can be. So you can set this candidate count higher if you want to, and the LLM will respond with more answers and also the associated metadata for these. Now, you can make use of this if you want to sample a variety of outputs, but usually it's recommended to just stick with one. There can be a cost benefit if you're doing this where you have a large input prompt and you want multiple answers for that input prompt, but usually the cost for the output is much higher than the cost for the input, so it doesn't really matter and just makes your post-processing a bit harder. So I recommend you sticking with the one approach. Then we are adding all of these variables here at the end, which enables us to extend our request to the model, like this. Now let's run this in our terminal with Python input understanding, and we can see nothing about the output actually changed here. That's to be expected, but good to confirm. Let's jump over to the SAS code, where I have done a bit more changes to make future configurations easier. Now, in addition to adding the same input configurations, you can see I also moved the prompt and system prompt up. This is because I have now moved the generation of the input from a singular string into a data step, enabling us to write the whole request to a JSON file or temporary file that we then pass into the proc HTTP request. I've set this file name to be temporary. If you want to see what it looks like, you can just take the path that you're in and add it in here and say like test.json, for example, and you will see your request being printed to the actual file. And you can also rerun it and will overwrite that file. But exact same principle as we saw in Python. And then we just pass that request body into our proc HTTP. Let's run our code and just confirm that it also works the same as did our Python code before. Now we get back our response as we expected, so everything is looking fine. Well, look forward to next week's episode where we will restructure our code a bit, make it more flexible, more reusable to set us up for the future to iterate faster. Let's see what's going on there. See you next time. Bye bye.